Okay guys, Assalamualaikum and good afternoon. Can you guys hear my voice?
Dengar sir.
Boleh, okay. Alright, so as usual, today I would like you guys to try first to obtain the solution for tutorial 2A, okay, which I have already uploaded in the PLE lah. Okay, so this is tutorial 2A, so you download it from here. I want you guys to try to obtain the solution first, and then I'll give you about, now is 12:17, 12:20. Okay, so I'll give you about 1 hour lah, sampai lebih kurang 1:20, and then we will discuss the solution. Is it okay? Boleh ke? Ya. Okay, so just biar je Teams ni on. Nanti 1:20 kita akan terus start with the discussion. But first, please get your solution first. Buat setakat yang you boleh buat lah. Kalau boleh habis, if you can finish the solution, then Alhamdulillah, that is good. If you don't, but it is okay. I will discuss with you the solution later on. But please try, okay? At least you know how to answer them. Right, most of the solution you may find it from our lecture notes lah. Okay, okay, you may start now. I'll be here. I'll be on the Teams for all the time lah until 1:20. Should you have any question, you can ask me. Okay, right. Please proceed, guys. Okay guys, boleh kita start discuss the solution? Can we start now?
Yes, sir.
Boleh Alright. Okay, so tutorial 2A is regarding the investigation into the MSIICs. Okay, the topic that we have learned last week. Okay, 2B is going to be starting only tomorrow. So that's why saya pecahkan tutorial ni kepada A dengan B. Okay, so that you will not get confused later on. Okay, so 2A is about decoder and encoder. Alright, so if you look into the first question, draw a block diagram of a decoder and explain its application. So you may find the solution here in my notes lah. A decoder accepts a set of inputs and represents a binary number and activates only the output that corresponds to the input number. Okay, so ini dia punya block diagram. Right, ini memang saya ambil, memang sebiji dalam nota saya. You will find it in my notes. Then referring to figure 1, question 2, answer the following question. So this is A, B and then W, X, Y, Z. So means that you are having 2 to 4 input decoder. 2 to 4 decoder. So determine the circuit truth table. So this is the truth table, but you have to change the variables lah. Here dekat sini dia saya letak sini X, Y, output dia F0, F1, F2, F3 dekat dalam notes. But in the question it is A, B and then it is W, X, Y, Z. So just change this X to A, Y to B, F0 to 1, F1 to X, F2 to Y, F3 to Z. So this is the truth table. Then explain the circuit operation. So a decoder that accepts 2 inputs and produce 4 outputs. And it's using AND gate will cause the output becomes active high. Okay, sebab ini guna AND gate. So bila AND gate dia akan jadi active high lah. This decoder can also called as a 1 to 4 decoder because only one output is activated at one time. Okay, ini semua dalam nota saya. You can find it there lah. How to make the circuit becomes active low? And then the answer is by replacing the AND gate in the circuit diagram to NAND gates. So all these 4 AND gates tukar menjadi NAND. So dia akan jadi active low lah. Right. So explain one disadvantage of this circuit. So yang ini basically you kena cari dekat dalam internet atau dalam buku lah. Alright. Saya just actually dia tak ada pun dalam notes, just saya nak bagi information for you, to all of you, so that you know this decoder has disadvantage jugalah, ada satu lah. Alright, so what is the advantage if both of the inputs are not connected, which is atau A dengan B ni ataupun dekat X dengan Y ni, they are not connected. Okay, maksudnya dia logic unknown. Dia X. Input dia bukan 0, input dia bukan 1. So, dia unknown. Okay, so when the input is logic X, the output will not remain as 0. Instead, the decoder will consider it as logic 0 and the bit 0 will made high. So, walaupun tak ada input, even though there are no inputs for this decoder, the output will become 0. Okay, and then it will also consider it as logic 0 and the bit 0 will made high. So maksudnya dekat sini let's say first you ada input 1 and then katakan sini output dia 0 0 0 1. And then suddenly then you bagi 0 1 1. So 1 1 dia akan jadi 1 0 0 0. Okay. And then tiba-tiba you cabut input ni A and B, you dismantle them, so there are no inputs here. So the output dekat sini dia akan still ada output tu walaupun sebenarnya input dah tak ada. Okay, so that is one of the disadvantage of this circuit. Okay, supposedly kalau tak ada input, so dekat sini tak ada output lah. Tapi bila dia tak ada input, dia still ada output. Alright. And then E, modify the circuit to solve the problem in D. Okay, so this is the problem. How you solve the problem by adding an enable E input to the diagram. So kita masukkan enable ni. Okay, kita masukkan enable input dekat setiap AND gate ni. That will solve the problem that happens in D. Yang berlaku dekat D ni. Right? So basically in the notes you may find A, B, C and E lah. D ni dekat dalam internet sebenarnya. But it is you tak perlu risau sangat lah pasal benda ni. Okay, you just have to know basically normally dia akan minta the truth table, dia punya explanation, dia punya circuit diagram, dia punya block diagram yang inilah Question 1 tadi. Okay, question 3. Sketch and explain how to modify the circuit of part 2E may be used to implement a 3 to 8 decoder. So kita guna circuit yang kita dapat dekat 2E ni tadi to become 3 to 8. So dekat sinilah, this is the solution lah basically. Okay, so each of these 2 to 4 decoder dalam tu ada ini. Alright, so you may draw them the connection dalam dia macam ni, tapi dia punya output, input dan output dia macam ni lah. So this is A2 will be entered to the enable input. A1 and A0 is for A and B, or X or Y, whatever variables that you are using. Okay, so ini ada dalam notes. Macam mana nak jadikan 2 to 4 decoder menjadi 3 to 8. You can assemble them to become 3 to 8. Just make sure you have to use the 2 to 4 decoder which comes with enable. Tak ada enable, tak boleh jadikan dia 3 to 8 decoder. Question 4, figure 2 shows a generic 3 to 8 decoder IC. With help of a diagram, show how it may be used to implement a 4 to 16. So ini adalah 3 to 8 decoder with enable. So lebih kurang jawapan dia macam question 3 ni tadi. Okay, but now we are using 3 to 8. So you have 3 inputs and 1 enable input W, connectkan pada dua-dua. Output dia D0 until D15. D0 until D7 for the first 3 to 8 decoder. D8 until D15 for the second 3 to 8 decoder. Okay. So ni saya ambil dari note saya ni. Diagram ni saya ambil dari note saya. Alright. Okay, question 5. Design a 4 to 16 decoder using 2 to 4 decoder. So yang ini obviously they are not listed in the notes, but you can find them easily in the internet lah. You type di situ 4 to 16 using 2 to 4 decoders. So this is how you obtain it lah. So basically you have to use 5 2 to 4 decoders. So the first one has the first two input, which is A and B. Okay, and then the other 2 to 4 decoders is the decoder with enable input. Yang ini tadi tak perlu. Okay, where the input of A and B will becomes the enable input of these 2 to 4 decoders with enable input. So dengar output dia F0 ni jadi enable untuk 2 to 4 yang pertama. Okay, yang ini 2 to 4 yang kedua, yang ini 2 to 4 yang ketiga, yang ini 2 to 4 yang keempat. And then the 2 to 4 ni enable dah ada, XY ni datang daripada CD lah for each of them. So you can get a 4 to 16 decoder from 5 units of 2 to 4 decoders. Cantumkan macam ni, you dapat 4 to 16 lah. Okay, this is actually an application for basically you can use them bila you dalam lab biasanya. Okay, normally let's say you tak ada IC 4 to 16 tetapi you ada banyak 2 to 4 punya decoder. So you may connect them like this, automatically you will have your own 4 to 16 decoder. Right, sama lah macam ni. You ada 3 to 8 tapi tak ada 4 to 16, so you combine 2 3 to 8. You ada 2 to 4 tapi you tak ada 3 to 8, so you combine 2 units of 2 to 4. So you dapat 3 to 8. Okay, so that is number 5. Number 6, draw the block diagram of an encoder and explain its application. So this is the diagram. You may find them in my notes as well as this one lah. An encoder performs a reverse decoder function where it accepts an active level on one of its inputs representing a digit such as a decimal or octal. So input dia dalam bentuk nombor bulat, yang nombor yang kita pakai hari-hari lah. And then it will convert it into a coded output such as BCD or binary. So dia terbalik kepada decoder. Decoder input dia masuk dalam binary, output dia keluar 1 dalam bentuk decimal. Encoder, the input is in decimal, the output will be converted into binary. Okay, so that is the function of an encoder. So if you know what decoder is, then it is very easy for you to analyze what encoders are. Okay, just terbalikkan sahaja. Even the truth table pun sama, terbalikkan. 2 to 4 decoders, you terbalikkan input dengan output, you akan dapat 4 to 2 encoders. So it is very simple. Okay, number 7 referring to figure 3. So this is figure 3. Answer the following questions. Determine the circuit truth table. So if you look into this, what we call it, this truth table, you have decimal digit from 0 until 9. Okay, so meaning that sekarang ni dia adalah encoder yang mana boleh convert decimal number, iaitu dari 0 sampai 9 sahaja, and then to becomes a BCD code. Okay, I already told you BCD berbeza dengan binary in terms of how they are represented. Dia punya representation dia berbeza. Even though they are using the same base, iaitu base 2. Okay, means that you have to know perbezaan antara BCD dengan binary lah. So if it is 0, it will become 0000. If it is 5, 0101. If it is 9, 1001. Okay, so dekat sini kita tahu this is a decimal to BCD encoder. Okay, so determine the circuit truth table. So this is the truth table. You may find it in my notes. Ada dalam notes. Ini pun saya ambil daripada notes saya. And then explain the circuit operation. So this type of encoder has 10 inputs with 1 for each decimal digit and 4 outputs corresponds to the BCD code. Okay, so satu input untuk setiap nombor bulat dan output dia ada 4 dalam bentuk BCD. Example, input 9 high, all other inputs low. So output A0 and A3 will be high and output A1 and A2 will be low. So BCD code 1001 for decimal 9. So kita tengok betul tak? Bila ini high, yang lain semua ni low, this one becomes high. A0 and A3 will becomes high. A1 and A2 will become low. So dia akan represent nombor 9 dalam bentuk BCD code iaitu 1001. So what is 1001? 1 is 8, this is 4, this is 2, this is 1. So 8 tambah 0 tambah 0 tambah 1 dia jadi 9. Kita tengok another example. Number 6, 0110. So A3 and A1 is 0, A3 and A0 is 0, A1 and A2 is 1. So this is 8, 8 tak ada, so 0 tambah 4 tambah 2 tambah 0 jadi 6. That is how you obtain dia punya circuit operation. You boleh discuss semualah, tapi kalau kata keluar soalan macam ni dalam final, you just need to give an example for one decimal digit pun dah cukup. Tak perlu nak discuss sampai banyak-banyak lah. Alright, and then explain the disadvantage of the circuit. So if you look at this truth table, it can be identified that the disadvantage of this encoder is that it can only convert decimal 0 until 9 only. For numbers which are greater than 9, that needed additional encoder, as one encoder only represent one decimal digit. Okay, so maksud dia apa? Now we have 10 numbers here, 0 until 9. So if you are converting these to if you converting these decimal numbers, this will become the output. Okay, let's say sekarang ni you nak display nombor 9, then you boleh guna 1 BCD code. Now, katakan you nak display, you nak convert nombor 20. So if you are converting number 20, you can't convert them by only using one BCD code. You have to use another one. Because why? The first one is to represent number 2. The second one is to represent number 0, which is 20. So itulah dia punya disadvantage dia. Sebab dia hanya boleh convert kepada nombor 0 hingga nombor 9 sahaja. Kalau nombor 10 dah tak boleh. Nombor 10 you kena tambah lagi 1. So that is what this answer here is about. Okay, kalau this is for number greater than that, for numbers which are greater than that, which is greater than 9, needed additional encoder. Okay, as one encoder only represent one decimal digit. Okay, contoh saya nak, kita ambil contoh lah. Saya nak represent number 100. So if I want to represent now the number 100, what I need is, I needed 3 encoders. Okay, so saya perlukan 3 BCD encoder ni. Why? Sebab nombor 100, the first number will becomes 1, which is 0001. The second number is 0. So I need this to represent 10. Kalau saya nak represent 100, 100, then I need another one of this. So saya perlukan 3 BCD code, so 100. The first one is 0001, the second and the third one is 0000. Baru kita dapat nombor 100. So that is basically the disadvantage untuk decimal to BCD encoders ni lah. Okay, not really a disadvantage lah, cumanya it is a limitation lah untuk penggunaannya sebab it can only convert 0 until 9. It cannot convert 0 until 10. Tak boleh. Dia boleh 0 until 9 sahaja. So that is the limitation. Okay. So are you guys okay with the solution? Yeah.
Untuk 2E tak saya kata.
Tak dengar. Kuat sikit. Tak dengar.
Sekarang dengar tak sir?
Dengar.
Boleh tak kalau 2E tu saya kata cannot make 3 to 8 line decoder.
2E ni kata tak boleh?
Sorry sir, 2D.
2D, okay. Maksudnya?
Saya kata advantage, disadvantage. Kan untuk convert 3 to 8 line decoder.
Maksudnya daripada yang apa ni, from the, mana lah saya dah pangkah tadi. From 2 to 4 decoder, dia tak boleh jadi 3 to 8 decoder.
Yes. But dia
yes. Boleh juga. Yes, tak ada masalah. Itu, that is also one of the solution. One of the disadvantage. Sebab
lepas tu sir untuk yang last question tu, question 7 I think.
Okay.
Dia punya disadvantage kan 0 until 9 tapi only for MSI IC kan?
Yes.
Thank you sir.
Okay. Putus-putus, saya tak dengar sangat suara you. Okay, any more question? Ada soalan ke, guys? Yang lain-lain? Okay, macam saya cakap tadi, most of the solution you may find it in my notes lah. From my notes, you can get it there. Ada certain je lah 2-3 soalan yang you have to find them from books or from the internet lah. But it is very easy to find pun sebenarnya. You type je dalam Google, memang you boleh jumpa lah. Okay, alright. Ada soalan lagi tak, guys?
Tak ada, sir.
Alright, if there are no questions, then I will share you your attendance. L01 B02. Okay, please scan your attendance ya. Okay. Afiq Hafiz, Ezaimi
Yes,
ada
sir.
ke?
Ya, Hafiz.
Afiq Hafiz ada. Ezaimi ada. Ezaimi tak ada. Okay, so I think that's it for us today. Inshallah, I'll see you tomorrow for the lecture of 2B. And then I will hand it out to you your assignment 1 tomorrow lah. Bukan assignment 1, assignment task 1 tomorrow untuk you all start buat dah. So what I would like to suggest to all of you is to look for a partner. Okay, so dah boleh tengok partner. Bukan dari kelas ni saja. Kalau you ada partner daripada kelas yang lain. Maksudnya with your friends who are in the same lecture with me. You L01 B02, kawan you ada L01 B04 macam tu. So you boleh combine dengan dia pun tak ada masalah. It is okay. Jangan combine dengan kelas yang bukan dengan kelas saya, itu je. Okay, so you have to look for a partner. Tomorrow kita akan discuss masa lecture. Alright. Okay, last chance. Any questions? Ada soalan lagi? Okay, saya
Bisa, sir. Solution tadi saya dah upload dekat VLE ke?
Dah ada, tapi saya belum visiblekan. Nanti saya bagi dekat grup WhatsApp, grup kita ni sekejap lagi.
Okay, sir. Thank you.
Okay. Alright guys, I think that's it from me. InsyaAllah tomorrow I'll see you for the lectures. Okay, thank you. Assalamualaikum and good afternoon.
Thank you, sir.
Thank you, sir.
Sama.